There's both areas. If I added those two numbers up, I would have the area of that. Now the distance to the center of those areas from my red line. This plus a half puts me there. I need to be right here. So a half, 4.206. And center of this looks like that is, and if you take and you multiply those two numbers, all those numbers together, this 8 times 1 times that, and then these, you're going to end up with a number that adds up to this. Now if I go to the bottom, this would be this crosshatch. Areas of the two pieces, looks like 1 by 4. Takes care of the bottom. This looks to be $6.294. That's the area of that stem. Distance to the center, come back a half, minus a half, 6.794. Okay, make sure I got this. That looks good to me. And then distance to the center of this mess. Take that and divide it by 2. Add the two together, and I got that's a round off error. You can see it's 37.08 is my number, so it doesn't matter which half you pick. Take your choice. Whatever looks good to you and whichever one you can figure out the easiest, do it. So I'm going to put 3708 right here. Now I'm down to one thing. That's figuring out I. Okay, A8 in the back of the book may be of help to you. If that's not of help to you, hopefully the YouTubes were. If not, hopefully what I do here will help. Okay, I got to finish this chart. This is ZO. Excuse me, IO. IO. This is Z. AZ squared. Okay, IO. IO is the moment of inertia of the individual element about its center line. So I've got, what, 3 rectangles? If you go back to page 666 in your book, you're going to see a little picture, and it's got I equals BD cubed over 12 for a rectangle. That's why I put these in this order. BD. You don't have to think about it. Put them in there. 8 times 1 cubed over 12. Four times 1 cubed over 12. One half times 10 cubed over 12. Half times 10 cubed over 12. Add them together. That's 1, so it's 42 and a bunch of 6s. There's IO. Okay, this is a little bit of a problem here. Okay, I'm going to get rid of a couple lines on purpose. I'm going to get rid of that dimension right there, and I'm going to get rid of this dimension. Okay, I'll leave everything else. Everything else can stay. Okay, let me tell you what Z is. Okay, Z. Z is the dimension that goes from the neutral axis of the system to the neutral axis of the element. So here's the neutral axis of the system. Here's the element, so there's Z1. Here is Z2. And here is Z3. It's from the neutral axis of the system to the center of the element. So I got to figure these out. So if I'm at what? 4.7 minus a half, so this looks to be 4.206. This one looks to be that minus a half, so this got to be, that look good to you? I'm doing it in my head, make sure I'm right. And then this guy, it looks like if I take this and subtract y2, and y2 was 6, so if I subtract 6 from there, I've got 1.294. 1.294. There's my 3. Okay, put those in the proper spot. If you do that, you end up with 4.206, 1.294, and 6.794. And hopefully that's the same as I got over there. Looks like it to me anyways. AZ squared. A Z squared, put it there. Okay? So if you got AZ squared, and let me write them down here. 8 times 4.206 squared gives you 141.52. 5 times 1.294 squared gives you 8.37. And 4 times 6.79 squared gives you 184.63. Add those 3 together. You get 334.52. So this is the equation. If you go to the appendix A8, you're going to find out that I equals IO plus AZ squared is the equation. Okay? This is the IO. This is the AZ squared. IO plus AZ squared equals I. Add those two numbers together, and you get 334, let's see, what do I get? 377.18. That looks like a number that can go up above. 337.18. 337.18. Looks like they got all the spots filled. Now, you're going to make this mistake. I did it on purpose. Okay? Pounds, inches cubed, inches to the fourth, inches. Pounds per square inch. Inches to the fourth, inches. Foot pounds. I told you to put that into the equation. So when you get on a test, you're not missing it and ending up of 1/12 of what you should have had.